So let's take a look at the LINQ syntax. I'm going to show you how to do filtering, ordering, projection, grouping, and joining. So let's start with restriction. Back in Visual Studio, I'm still using the queries project that I showed you in the last lecture. You can find the source code in the supplementary materials of this lecture. So in the main method here, first we create a new context, and now the query. Let's imagine we want to get all courses in level 1. So var query from C in context.courses. So the first line always starts with from. Here we do filtering using the where operator. Now this is red because we haven't added using system.link on the top. So I'm going to resolve this. Okay, look. You need to add this on the top. Next, where c.level equals 1. And the last line should always be a select. So select C. As simple as that. Now we can have multiple conditions here. So, and c.author.id equals 1. Next, ordering. So back here, let's imagine we want to order all courses by their level. So for now, I'm going to get rid of this condition here and add order by c.level, or we can order by multiple columns. So first order by level and then by their name. If you want descending order, you can add the descending keyword. So we can add it here, for example. So order in a descending way by level first, and then within each level, order by name. So far we just selected C, which is the course here. But sometimes what we want to return to the client of this query could be a different object. One common case is optimization. Especially in web applications, we could have a complex domain model. For example, we could have a course object with quite a few properties. We may not want to return all these properties to the client, and that's for optimization. So in that case, we can create a separate class with fewer properties and project this course, this C here, into that class. Or sometimes you may not even want to create a separate class. You can use an anonymous object. So let me show you how you can do projection. So here, instead of selecting C, we type select new anonymous object, and we can give it a couple of properties like name equals c.name and author equals c.author.name. So we project that course class into a different class that has name and author. We have a group by operator in LINQ, but this group by is different from the one we have in SQL. In SQL, we use group by along with an aggregate function, like count, or sum, or max. But in LINQ, we don't necessarily use group by with an aggregate function. We use group by to break down a list of objects into one or more groups. So imagine this is our courses table. We have 4 courses, and note that 2 of them are in level 1. We can group these courses by their levels, and as a result, we'll get 3 groups. Note that each group has a key property, which is based on the level of the courses it contains. So our first group has key 1, and it has 2 courses, both in level 1. Our second group has key 2, and the third group has key 3. Now let's see group by in action. So back in Visual Studio, I'm going to get courses and group them by their level. So query equals from C in context.courses, group C by C.level. And note that this is red because we have not resolved the namespace. So Alt and Enter. We got system.link on the top. So group C by C.level into G. So G is another variable we are declaring in our query. And the last line, select G. So what we get in the result now is a list of groups. So let's iterate over them. For each var group in query, first I'm going to display the key of the group, which is the level of the courses it contains. So group.key. Now I'm going to display the courses in that group. A group is enumerable. It's like a collection, so we can iterate over it. So for each var course in group, right line, let's add a tab here, so \t, and display course.name. Let's run the application. Look, we have 3 groups, group 1, and here are 4 courses there, group 2 and group 3. So this is a great way to break down a list into different groups. And note that here we didn't use any aggregate functions like count or max. Now let me show you how to use an aggregate function like count with groups. So I'm going to get rid of these 2 lines. Imagine we want to display all levels and the number of courses in each level. I'm going to change this to something like this. So the first argument here is going to be the level, and the second argument in parentheses is going to be the number of courses in that level. So for this first argument, we're going to use group.key. That's the key of the group. And for the second, we're going to use the count method. So let's run the application. So in level 1, we have 4 courses, same in level 2, and in level 3, we have only 1 course. Next, joining. In LINQ, we have 3 types of joins: inner join, group join, and cross join. Amongst these, inner join and cross join are similar to what we have in SQL, but group join does not have an equivalent in SQL. So let's start with inner join. In a relational database, we use joins to link 2 tables together. So if we have 2 tables like courses and authors, we can join them to display the list of courses and their authors. Now, if you want to achieve the same thing with LINQ, you don't need to do an inner join. You can use the navigation properties of your entities to display properties of their related entities. Let me show you what I mean by this. So imagine we want to display the list of courses and their authors. Var query equals, so from C in context.courses, and let's do a projection into an anonymous object. Select new, course name equals c.name. This is not resolved, so Alt and Enter, import the namespace. Okay. So into this anonymous object, we're setting the course name, and now author name equals, so C, which is the course, dot author, as the navigation property, dot name. That's it. We don't need to do a join, because here we have navigation properties. And when we run this, LINQ provider at runtime would automatically translate this into an inner join in SQL. So you might ask, when do we use inner join in LINQ? We use inner join when we want to link 2 entities that do not have a navigation property. In this case, imagine we didn't have this author property on the course. Maybe we're working on a big complex model and there are lots of relationships, and we decided to remove some of these relationships to prevent cycles. In that case, in the course class, we would only have author ID as the foreign key property. So we can use inner join to link a course to its author. So this is how we do it. After from, join A Now note that here in the IntelliSense, the author class is selected. So if I press space now, we get author. And that's where IntelliSense gets in the way of typing. So let's undo this. See what I do. Join A, press escape, and continue. In context.authors. So look, it's very similar to from. From C in courses, join A in authors. Now join based on what? On C.authorID equals A.id. And note that we are using equals operator that belongs to LINQ. We are not using double equal sign. Sometimes I make this mistake and my query doesn't get compiled. Next, assuming that we don't have this navigation property in the course class, we can use a.name. So a is the variable that references an author. So this is one example of using inner join when there is not a navigation property or relationship between two entities. So we link them using a key. Now let's take a look at group joins. So as I said, group joins do not have an equivalent in SQL. This is how group join works. Imagine we have two lists, authors on the left and courses on the right. With group joins, we associate each object on the left with one or more matching objects on the right. You might ask, when do we use this? In my personal experience, I've found this useful in situations where you use a left join and an aggregate function in SQL. For example, you may want to get all authors and count their courses. With SQL, we do a left join between authors and courses in case an author does not have any courses. And then we use an aggregate function like count to count the number of courses. And finally, we do a group by. The way we achieve this with LINQ is using a group join. Let me show you how it works. Okay, back here, so we want to get the list of authors and join them with their courses. So we start with query from A in context.authors. Now we want to join them with their courses. So join C. Again, remember to press escape, otherwise IntelliSense gets in the way. So join C in context.courses. Join on what? On A.id, ID of the author, equals C.authorID. So this is exactly the join you learned a minute ago. The only difference with group join is when you use the into operator. So into G. So remember the into operator I showed you when we were talking about group by. So this part is the standard join, but when you use into G, the result will be a group join. With this, now when we do a select, as I said with group join, we link each object on the left side with one or more matching objects on the right side. So in this case, the left side is the list of authors. And for each author, we're matching it with one or more courses on the right side. So we get access to the left side. We can have a property like author name. And from the left side, we select a.name. From the right side, this is the right side. We get the list of matching elements, the list of matching courses. So, courses. I can put G here and get the list of all courses for that author. Or I can use g.count just to get the count of them. Let's look at the result. So for each var, let's call this X in query. Right line, I'm going to display the author, and in parentheses, I'm going to display the count of their courses. So X has a property called author name, and another property called courses. Run the application. There you go. So Marsha Medani has 3 courses, but John Smith does not have any. So that's why I told you we use group joins in LINQ in situations where we use a left join in SQL. And the last one, cross join. The cross join we have in LINQ is exactly the same as the one in SQL. Let's take a look at an example. So imagine we want to get list of authors and do a cross join with courses. So it will be a full combination of every author and every course. Again, query equals from A in context dot authors. Now instead of using join, we use from C in context dot courses. And now we do projection. Select new. Author name equals a.name. Course name equals c.name. That's it. That's a cross join. Let's look at the result. So I'm going to display author name hyphen course name. And run the application. So this is the full combination of every author and every course. Now, if this syntax has made you a little bit confused, don't worry at all. I know exactly how it feels. I have been in that situation before. It's just because you're new to this concept. So to make things easier for you, I have created a cheat sheet that you can download in the supplementary materials of this lecture. Whenever you get lost, just look at the cheat sheet, and after a few tries, you will fully remember the syntax. In the next lecture, we'll look at LINQ extension methods. I hope you enjoyed this lecture, and thank you for watching.